Hi everyone, this is Eve from the University of Warwick. I will share my work in the European Conference on Computer Vision 2024, and the topic is about ProTIP, which is probabilistic robustness verification on text-to-image diffusion models against the stochastic perturbation. And the text-to-image diffusion model is one kind of image generation model which can generate high-quality image from simple text descriptions. However, like other deep learning models, they also suffer from robustness issue. Like if there are some small perturbation in their input text, they will generate quite different images from the original one, because those perturbation will degrade their performance. And usually, the robustness is referred to a model's decision should remain invariant against the small perturbations on a given input. Typically, it's defined as all input in a small region have the same predictions. And when the perturbed example change the model's prediction, we usually call those perturbed example adversarial example. And for text-to-image diffusion models, we found this existing work just focus on those deterministic robustness, like the first three types described in the image. And there are few work care about the probabilistic robustness. Probabilistic robustness refer to the proportion of adverse example inside the small non-ball region. And the probabilistic robustness can tell how robust the model is whenever an adverse example is found. And especially when the model is large, knowing the proportion of adverse example is more relevant and is quite important for their real-world application. So in this work, we will focus on the probabilistic robustness of text-to-image diffusion models. So we developed a framework called ProTIP to evaluate the probabilistic robustness of text-to-image diffusion models. And this framework includes two main parts. The blue one is the inner loop, and the yellow one is the outer loop. The inner loop is about to indicate whether a perturbed example is an adversarial example. So I will introduce them in detail. First, the given an original input X, we will generate a perturbed example X prime. And we input those two texts into a text-to-image diffusion model like Stable Diffusion. Then the model will generate two set of images. And then we use clip model to convert the image into two set of clip score the data. And then we use statistical hypothesis testing to test whether the two group of data is from the same distribution or not. Because if they are not from the same distribution, which means the current X prime, the perturbed example, is not is an adversarial example, because they can let the model to generate a different distribution of data. And also, we introduce sequential analysis to speed up the indication process. So that's about the inner loop. And now we know how to indicate adverse example among the perturbed example. The probabilistic robustness is the proportion of adverse example over a population of all possible perturbations on a given input text, X, we call X here. Normally, this population is quite large, so we cannot detect them one by one. Thus, the ground truth can only be estimated as the sample mean drawn from the population. And we know no matter the sample size, there will be discrepancy between the sample mean and the ground truth population mean. Therefore, in the outer loop, we adopt the Hofstad's inequality to estimate the ground truth. And so using the two main parts, the inner loop and the outer loop, we can verify the probabilistic robustness of a text-to-image diffusion model when given a single input text. So that's all our work. And for more information, you can refer to our publication, and we are open to more improvement and discussion. Thank you for watching.